It's a while since we've worked with logs, so it's time to review our logarithmic functions. Now, you don't necessarily need to write any of this down because you already have it in your book, but it's important just to go through each skill and check that you still remember how to do all of these things. You should be able to rewrite exponentials as logs and vice versa. So take an exponential expression and remember we tell the story. Start with the base down here, 3 to the power of x equals 7. You should also know the change of base formula so that you can work out any log with any base using your calculator. So something like this same expression here, I can write it as a fraction using base 10 in both cases or base e in both cases. Now, the reason that I'd want to use base 10 or base e is that that's what my calculator works with. I've got the log button, which is log with a base 10, or I've got the ln button, which stands for natural log, which is working with a base e. Now, it doesn't make any difference which one of these buttons you use as long as you use the same one for the top and the bottom in both cases. You also need to know how to rewrite any number as a log or as an exponential. So I can take some number, say x, and I can write it as an exponential expression, given that if I'm writing it like this, x needs to be positive because I can't take the log of a negative number. Or I can write it like this, and this works for all x. Now remember, we also saw a workaround here in case we want to write a negative number in this form. What we could do is write the positive version of it. So let's say we wanted to write negative 5 as an exponential expression. We'll start by just writing 5, not negative 5. We know that we can write it like this. And now if you've got negative 5 instead, you're multiplying this whole side of the equation by negative 1. So it stands to reason that you're going to need to multiply this whole side by negative as well. And the negative will come out the front here instead of going up here because we can't take the log of a negative number. Now, we also should understand log graphs. We've looked at these before and we've seen that the graph y equals log of x with the base e is really just a reflection of y equals e to the x around this line y equals x. And we can tell that because if we rewrite this function as a log, we would say e to the power of x equals y. Or in other words, x equals the log of y. Now that looks exactly like this one, except the x and the y have been swapped around. And we know that when you swap the x and the y around, it actually flips or reflects a graph around this line y equals x. We've seen this before with parabolas. We looked at y equals x squared, which we know looks like this. And yet if we swap the letters around and say, what about x equals y squared, then it literally flips it this way. And you'll see that that's actually a reflection around the line y equals x that flops it over this way. So the same situation here. So because these graphs are so related and all of their coordinates have this symmetry going on, we get some interesting things. We can see that they're reflections of one another around the line y equals x. The domain of one graph will be the range of the other. Okay, so the domain of this red one is all real x, and we can say that the range of the log graph is all real y, whereas the range of the red one would be y must be greater than 0, and that's exactly what the domain of this one is, x it has to be greater than 0. Other interesting things, one of the graphs is concave up, the red one, the other one is always concave down, and the asymptotes and intercepts are just swapped with x and y values. So just as we know that this exponential graph goes through 1 here, the log graph also goes through 1, but on the other axis. And while our exponential graph has got an asymptote on the x-axis, the log graph has its asymptote on the y-axis. And both graphs are 1 to 1.